In this presentation, we are going to review the process of impact assessment and discuss how EFLOws are incorporated in assessment processes. We will describe the different steps of the impact assessment process, focusing on environmental and social impact assessment, or EIA, and also cover how EFLOws are integrated in some examples. Impact assessment is a process that will analyze the positive and negative consequences of different human interventions. This can be specific projects, policies, laws, plans, or programs. Impact assessment aims to preserve the integrity of ecosystems and contribute to make development sustainable. An environmental and social impact assessment report gives all the stakeholders information to decide if a project is acceptable when considering the trade-offs between the impacts and benefits. The assessment integrates environment and society in development decisions, going beyond the technical or economic feasibility of a project. We will cover the different steps in the process. We start first with screening. But it's important to mention that this is an iterative process because the assessment needs to be adjusted as new information is generated or the circumstances change during the time of the assessment. So the first step is screening. This is the time when the decision must be done if an assessment is required for the specific intervention and what type or level of detail it will have. Most countries have environmental laws and regulations that specify the type of EIA required based on the specific type of project, for instance, a dam, irrigation project, a factory, and the size, for example, the capacity of a dam. Also, this type considers the severity of the expected impacts. Some projects might be expected to have minimal impacts, while others might have severe impacts. This screening might be done also sometimes based on a checklist, based on the list in the regulations. And for simple projects, there might be already predefined mitigations. For larger projects, the assessment might need to be more comprehensive and also it must be carried by interdisciplinary teams. The second step is scoping. In this step, the terms of reference for the assessment will be prepared by the authority, and these terms will indicate the minimum aspects or potential impacts that the assessment must cover. This stage includes identifying stakeholders and identifying the preliminary impacts that are expected. An important activity in this step is to define the spatial and temporal boundaries that the assessment will use. Regulations in many countries require assessing alternatives for the project. And for example, those can be alternative locations for a dam or different technologies that will reduce water usage in industry. In impact analysis, different studies will be conducted to determine how the works and activities of the project will affect negatively or positively the different environmental and socioeconomic components. This information is integrated to determine the significance of the impacts based on criteria such as frequency, geographical extent, magnitude, and duration of the expected impact. Once the impacts are identified and determine how significant they are, each impact needs to have a mitigation. Then, This mitigation will be used to determine how the remaining impact will be. This is called the significance of the residual effect. If the mitigation does not prevent the impact from happening completely and only reduces it in magnitude, extent, or any other criteria, there still will be a resulting impact or residual effect. So then the consultants that are doing the assessment need to apply the same criteria to this residual effect to determine how significant it is, because that is the part of the impact that will remain and that will still determine changes in the environment. If the mitigation is not very effective, it will be needed to look for other alternatives, other mitigations. But if there are no other mitigations, then this residual effect will be very important to decide if the project should continue or be approved or not. Once the mitigations are determined for all the impacts that are considered significant, these mitigations need to be compiled in what is called the Environmental and Social Management Plan. This plan is the tool that will help manage these mitigations and control the impacts that the project can cause on the environment. It is very important that this plan will inform who is responsible for applying specific mitigations, because if not, it will not be very useful for implementations if the project is approved. So after the mitigations were identified, the consultants need to write the report. Sometimes it is called an environmental impact statement or environmental and social impact assessment report. This will include information about the project, how the assessment was done, and what were the results of the different analyses, especially the determination of significance of the impacts. It will also contain the environmental and social management plan, summarizing the different activities that are causing impacts, the mitigations that are suggested, the significance of the residual effect, and will specify who is responsible for implementing and monitoring the mitigations. This report is sent to the authorities to review. During the revision, if there are concerns of impacts that the report did not cover or did not explain satisfactorily, the reviewer will send back the report to the proponent. Then, he and the consultant need to correct any deficiencies and send it back to the reviewer. This might be repeated until the reviewer is satisfied that the report covers all the aspects that are necessary. Then, after the reviewing, the next step is the decision. So, deciding if the project is approved, considering the impacts and benefits, might be done only by the authorities, or it might consider public consultation. In some cases, different stakeholders will be involved directly in the decision through panels. How the decision is done will depend on the regulations of each country. Follow-up is the last step if the project is approved. Follow-up involves the implementation of the environmental and social management plan that was produced as part of the assessment. That means that follow-up does not finish when the project is approved, but it continues during the life of the project, because mitigation should be required for the construction phase, for the operation phase, and, if applicable, to the end of life of the project, which would be the decommission of any infrastructure that is left once the project ceases to operate. You have noticed the different yellow stars in the diagram. So this indicates different steps in which the input of stakeholders is very important. Of course, depending on the regulations of each country, participation might be very limited or might be done during different steps. For example, during the scoping, stakeholders might give feedback on the terms of reference that will determine the content of the assessment. During impact analysis, it's not only consultation with those potentially affected by the project, but also incorporating local knowledge to know in more detail how the project will affect the environment and people. In some countries, it's very common to submit the draft of the report for public review. And if that happens, all those that are interested in the project might submit comments to the authority that should be addressed by the proponent. And these comments should also be involved in the decision or integrated in the decision. And I mentioned before that in some countries, stakeholders might be involved in the decision, for example, if there are review panels. Those panels will advise the Ministry of the Environment about the possibility to accept the project or some reasons why it should not be approved. Finally, during follow-up, stakeholders also can have a very important role because they can help monitoring that the mitigations are in place and are working as they are supposed to. As it was mentioned before, it is very important to define the appropriate spatial and temporal boundaries for the assessment during the scoping stage. The temporal boundaries might include the past to know what activities that happened before could interact with the project and increase the negative or positive effects of it. It is also important to consider a period larger than the expected life of the project to know which future foreseeable activities that could be implemented in the region could interact with the project to also increase the benefits of impacts that are expected. And these are the case of cumulative effects. Also, once the project reaches the end of its productive life, the report must set guidelines for the decommission of infrastructure and the restoration of land. The special boundaries should include an area larger than what the project footprint will cover. You can see it in the diagram by this red circle. There is need to consider the project's direct and indirect zone of influence because the impacts will not be limited only to the space where the infrastructure is located. If applicable, transboundary effects also need to be included, and these are those that directly or indirectly occur because of the project in other jurisdictions, for example, other province, other basin, or other country. Projects that affect river systems might have transboundary effects. It is very important that the assessment considers multiple boundaries because different social and environmental components have different habitat and resource needs. For example, different species use different parts of the environment or different types of vegetation, also during different stages of their life. Different groups of people might use different resources and share other ones. Also, the definition of the spatial boundaries is the basis to identify the stakeholders that need to be involved in the project. In impact assessment, e-flows are assessed as part of the changes that the project might have on the hydrology of the study region. The assessment should consider first how the project will modify water and sediment regimes, and this will be the foundation to determine how those changes could affect the living organisms that depend on the flow directly or indirectly. Also, how it will affect people that depends on the ecosystem services resulting from the river system. There is need to consider also non-living components such as water-related geological or landscape features, waterfalls, ponds, hydromorphology, etc. It is also important to consider during the assessment that flows are essential for fish, but also for several terrestrial organisms. So a tool to bring more attention to the importance of e-flows is the assessment of ecosystem services. This can be part of the impact assessment and focus on the services provided by flows and the dependencies of people on those specific services. The changes in flows will be related to changes in the provision of or demand of services and the access to them. In previous units, you have learned methods to assess e-flows. Those methods can be used in impact assessment, but in practice, their use might be limited by the regulatory timings that the authorities require. In other cases, because data availability or lack of it, or constraints in budgets. Ackerman and Dunbar specify that some methods are objective-based. This means that a first step for their implementation is that the stakeholders should agree on objectives that will express the desired condition of a river based on ecological, economic, or social aspects. For example, the EU guidance for e-flows indicates that a good ecosystem status should be defined for different European rivers. The objectives might reflect conditions needed to support the specific uses. For example, maintaining floodplains, consider recession, agriculture, or ensuring river rapids for recreation activities. Economic valuation might assist in the assessment of the trade-offs of modifying river systems. Caroli and co-authors use an eco-hydraulic modeling approach to assess run-of-the-river hydropoietic systems on the Upper Nis River in northern Italy. One of their conclusions was that the economic gains of power generation were similar to the loss of tourism revenue that resulted or could result from the decrease on rafting attractive of the river systems. Ackerman and Dunbar classify e-flows methods into major categories. Environmental flow approaches include lookup tables, desktop analysis, functional analysis, and hydraulic habitat modeling. They consider holistic approaches as other category. Lookup tables contain hydrologically defined indices. An assumption is that the indices should be based on statistical analysis of natural flow regimes, but sometimes they can be based on general observations. Indices based on variable percentage of monthly median flows will be preferred over those that use mean annual flows. These methods are easy to use but do not have ecological relevance, and the values cannot be transferred to other regions easily. Desktop studies rely on the analysis of existing data. Some methods are based only on hydrological data. Others combine hydrological and ecological data. The indicators of hydrological alteration are the basis for several desktop methods. Methods that use ecological data estimate statistical relationships between independent variables related to flows and dependent variables related to biotic elements. The main limitations of these methods might be the scarcity of information and the difficulty to derive biotic indices that respond only to flows. So other types of methods, functional analysis methods, rely on the understanding of functional links between the ecology and hydrology of river systems. These methods integrate hydrological analysis, hydraulic information, and biological data. They often rely on teams of experts from various disciplines who make judgments about the consequences that variations on flows and quantity and timing might have on ecosystems or specific species. Physical habitat modeling and habitat suitability models relate the physical conditions of rivers, such as water depth, flow velocity, and wetted perimeter, with habitat requirements of specific species, such as food, shelter, nesting, or spawning sites. These consider the life cycle of the species to define functional relationships that can be used to analyze scenarios for river flows. So these scenarios might be also used to estimate the magnitude of the impacts. Holistic methods aim to assess whole ecosystems, including species sensitive to flow changes and characteristics of hydrological regimes. These might be floods, droughts, and water quality. They also aim to include human needs. Determining the significance of impacts is a key activity of the assessment process. In the case of EFlows, political and social values that guide the definition of desired conditions for river systems and ecosystems might influence decisions on how significant the alteration of flow might be. The determination of significance should be based on ecological and social values and be supported by technical aspects, including hydrological and ecological characteristics, and monitoring data for biological indicators sensitive to hydrological alterations. The information will tell the extent of impacts on biological and human communities. The values of the indicators should be translated into the ability to achieve desired conditions for rivers once a project is implemented, and also the effect that changes in flows will have on other uses and the livelihood of people. For example, if the changes might increase the vulnerability of communities to drought or floods will affect their livelihood. When there is not enough data to inform the assessment, it might be difficult to assess significance, and it will be needed to rely on expert opinion. There are cases in which the regulation is very restrictive, and the determination is done considering if the change is consistent with values specified in the regulation, such as the maintenance of a flow that is equivalent to 10% of the annual average runoff. This approach is not recommended. We talked before about mitigations. So applying the mitigation hierarchy is more a political than a technical process. The assessment of e-flows, especially when it's related to changes in ecosystem services, gives information that the stakeholders can use to negotiate ways to achieve the desired condition for a river or to decide appropriate compensations for the losses of services or other goods. Best practices for impact assessment state that the priority should be given to avoid negative impacts. Avoiding impacts implies preventing human harm and irreversible loss of biodiversity and related ecosystem services. When it is not possible to avoid impacts, one should aim to reduce the impacts. If that is not possible, then the next would be to repair the damage, and only if there is no other option, to compensate for the impact. An offset occurs when the compensation will happen in another place, not where the impact had occurred. Compensation and offsetting are the last resorts. However, it is also possible to include measures to increase the benefits. This is called an enhancement. Although the aim is to avoid impacts, sometimes policies and regulations set exceptions. This is, for example, when it is argued that a project is in the national interest. I mentioned before the Environmental and Social Management Plan. Every report must include it, and it will summarize the results of the assessment. Because it specifies the mitigations that are needed to manage the impacts, it becomes a tool for accountability. This will be used by authorities to inspect that the proponent is applying the mitigations during the construction and operation of the project. The structure and minimum elements of a management plan are defined in regulations or other guidance. For example, the standards set by international banks that finance projects. Commonly, the plans are summarized in tables that specify the mitigations for different impacts and the entities responsible for their implementation. But in some cases, there might be large documents that detail specifically what has to be done, when, and by whom, and the objectives that will be achieved by implementing each mitigation. Donor organizations such as the International Finance Corporation or the Asian Development Bank have standards of safeguards that specify the requirements for the management plan. These include, for example, the environmental and social components that are affected, the anticipated impacts, the mitigations for each impact, the roles and responsibilities for implementing the mitigations, monitoring and reporting procedures and schedules, costs and sources of funds to implement the plan, and performance indicators to evaluate implementation. For large projects, there might be different plans for environmental and social economic aspects. If the project involves the relocation of communities, there must be a relocation plan that must have been agreed by the affected communities, the proponent, and the authorities. We are at the end of this presentation. So let's review some key points. So impact assessment is a tool to analyze the changes that proposed developments might have on how flow regimes and the associated ecosystem services and biodiversity might be affected. Impact assessment integrates different hydrological, ecological, and holistic methods for assessing inflows. However, in practice, the assessment of inflows might be limited by job budget, availability of data, or time set by the EIA process. It is important to consider the cumulative effects of multiple activities on inflows, biodiversity, and ecosystem services. Finally, the environmental management plan is a key tool for implementing mitigations when projects might affect the environment and, in our case, flow regimes. This is important to assign responsibilities and setting performance indicators, so these plans become accountability tools. So we conclude part 1. Then watch part 2 to review some examples of how flows have been considered in some environmental and social impact assessment reports.